Hello everyone, this is Unit 4, Lesson 1. We're going to solve for a solution to a system of equations by graphing. And I'm going to do this by hand for the first one, and then I'll show you exactly how to use the graphing calculator to graph and get all the coordinates and all of that. But first, we are going to go ahead and by hand identify the slope. Right? A lot of people just put 1 underneath. Remember, you need rise over run to graph. So it needs to be in a fraction. So the slope is -3. It's always the number before the x. And -3 over 1 is the same thing. And the other number, this number right here, is the b. And remember, it has to be in that format, y equals mx plus b, to identify the slope and the y-intercept. So, since we have the rise as -3, you want to put an arrow, a directional arrow right next to the rise of -3. That means it's down, it's negative. And then the +1 is to the right. It goes to the right. And we are going to start with the y-intercept of 3. So we're going to go up and put a nice big point on 3. We're going to go down 1, 2, 3. And to the right 1, following the directional arrows, then down again 1, 2, 3, and right 1. 1, 2, 3, right 1, 1, 2, 3, right 1. This is actually easier than using the calculator. Then instead of going down 3 and right 1, you're going to go up 3 and left, continuing the pattern of the points. So we're going to take the arrow, your ruler, and draw a straight line connecting all of the points. Just remember, when you draw that line, go beyond the last 2 points and put an arrow on each side and label the line with the equation in y equals mx plus b format. Y equals -3x plus 3, and that's the first line. Take a look at the second line. The second line is not in y equals mx plus b format. So we are going to have to solve it for y. The first thing that you do is to try to get y alone. So to do that, you need to get this 4x over from the left side of the equation to the right side of the equation. Remember, the 4x and the 20, the -20, are not like terms. So that means that you cannot combine those. So on the left side, you're left with 4y equals, and I'm going to put this 4x first, just to put the x first. Remember, it's y equals mx plus b, so I like to have that x first, and then the -20 is second. Then to get the y alone, you do the opposite of multiplication, which is division. You divide by 4 on both sides, you get y equals. And then we're going to do kind of like a butterfly method right here. This is 4 divided by 4, right? If it's 4 divided by 4, that's 1. And the x is just kind of hanging out there. It's 1x. You don't write 1x, you just put x. And then you do -20 divided by 4. -20 divided by 4 is -5. So the slope is 1 over 1. And then the y-intercept is -5. You're going to go down 1, 2, 3, 4, 5. And you're going to go up 1. That's a positive. You go up and to the right 1. So up 1 to the right 1 is just what I'm doing right here. A slope of 1 is kind of easy. It just goes into the corner of each box. Just like that. And then down 1 and to the left 1. And you continue that pattern in the corners of each box. And let me see if I could draw that straight line connecting all of the points. And remember, don't forget the arrows on each end. And then labeling the line is y equals x minus 5. This right here is known as the solution, where it crosses. So it is 2, -3. So the solution is always a coordinate to -3. And that's that point right there. Hope that helped. All right, so this is basically a flashback to Unit 1, solving equations. Just remember, every time that you have x's, variables on both sides of the equation, you always try to get the smallest over to the largest. But the main thing is that they are on one side together. All right, so this cancels, and you have 2x plus 8 equals -14. And then you subtract 8 on both sides. And these cancel. You have 2x equals, and -14 minus 8. You could even put this into the calculator. It is -22 if you need to. And you divide by 2 on both sides. You always use inverse operations. X equals -11. For this one right here, remember, every time you see parentheses in something like an equation like this, you are going to use distributive property. So it's +2 times a -2, and that is a -4x. +2 times +5, that's a +10, equals 15. Now look at just this equation here. We have a lot of terms. Actually, we have 2 terms on the left side that can be combined. And just so you understand what I'm talking about, there's the -3x and the -4x that could be combined right there. And 3 minus 4 is -1x. So I'm just going to put -x plus 10. I'm going to bring down that plus 10, bring down the equal sign, bring down the 15. Then I subtract 10 on both sides. And once you do that, the 10s cancel on the left side, and you bring down -x equals 5. Then I'm going to divide by, there's really a -1 that's right next to the x. You have to divide by that -1, because remember, you have to have a positive x that you are solving for, and the answer is -5. For this one right here, it says find the equation of a line that passes through the points -1, 2 and -3, 6. I don't want you to get confused about what they're asking you to do. They're just asking you to find the equation of a line that passes through those points. So the first thing that you have to do is label x1, y1, x2, y2. Remember, the equation of any line is y equals mx plus b. That is the equation in slope-intercept form. That's what everything boils down to, slope-intercept form. So you need the slope and you need the y-intercept. Now I'm looking for the x of 0, and I don't have an x of 0, so I don't have the y-intercept. We'll worry about that later. So far right now, the first thing that I'm going to do is to just write down the slope formula is y2 minus y1 over x2 minus x1. I am going to now just substitute the numbers in. My y2 that I labeled is 6. The minus sign is from the formula, and my y1 is 2. My x2 is -3. The minus sign is from the formula, and then I have a -1. Anytime that you have a double negative, just go ahead and put a positive down. So we have m equals, and you put this directly into the calculator. When I say directly into the calculator, let me get out of here like this. Press alpha x, you have your fraction, and then you have 6 minus 2 as the numerator, and the denominator is -3 plus 1. And you get -2 as your answer. So -2 is the slope. So now we have one part, but we're missing the y-intercept. This is where you could do one of two ways. The point slope formula is the first way that I would say it suggests to use. This is the point slope formula. You do not get that. It's not given to you. The second way you could possibly do this to solve for the y-intercept is y equals mx plus b. So I love the point-slope formula, but if you can't remember it or if you're not going to study it, then it's very difficult to use because you're not going to know the formula. It's y minus y1 equals m times x minus x1. So the y comes down right here as y. The y1, I already have it labeled as 2, so I'm going to put that in as 2. The m that I found, the negative 2, is the slope. The x stays x, and then the x1 is negative 1. So the minus comes from the formula, and the negative 1 goes in the, you're substituting negative 1 in as x1. And remember, that makes a double negative, and I'm changing that to a positive right away. So I have y minus 2. I'm going to bring that down, and then I'm going to do distributive property, negative 2x minus 2. Negative 2 times positive 1 is negative 2. Then I'm going to solve for y. Once I solve for y, I have my equation. It's done. The 2's cancel out. The y comes down, equals negative 2x. The negative 2 and the 2 cancel out to 0. You could put y equals negative 2x. How you do this, that was the first method. Now the second method, you could just use y equals mx plus b if you forget about the point slope formula. So the y is my y1. I'm just going to put that in as 2. The slope, which is m, is negative 2. The x, which is the negative 1, right here, I have it labeled. And then you leave the b because that's what you need. That's what you're missing. So you have 2 equals negative 2 times negative 1 is 2 plus b. And then you subtract 2 on both sides. And once you subtract 2 on both sides, you realize that b is 0. This actually cancels, and b equals 0. Soon as b equals 0, you know that you have the y-intercept as 0, and you have the slope, and you put it in y equals mx plus b, and you have y equals negative 2x. Either way, it will get you the equation of that line. So I'm going to do a couple more with you, and then I am going to just graph it without doing it on the screen. This m, so the first thing that you have to identify is the slope. You put 2 over 1. The b is negative 3. It's the other number. Remember, this is in y equals mx plus b. Once it's in that format, you could just go ahead and put the arrows of a rise and a run. Everything's positive. You start, except for the y-intercept, you start at negative 3, and then you rise 2, run 1, rise 2, run 1, rise 2, run 1, and you are off to the races here. Then down 2, left 1, down 2, left 1, and then you're ready to connect, not like that. You're ready to connect all of those points with a straight line. You're putting arrows on each end, and then you're labeling y equals 2x minus 3. This slope is, there's a 1 next to this, so if you put a 1 underneath, that is 1 over 1. That's the slope. The y-intercept is the negative 1. Remember, you put the sign of the number with the number for the y-intercept and the slope. So you start out with negative 1. It's right here, and I would like blue. Right? And then you rise 1. You run 1. And just like this, you're in the corners of each box. 1 is the easiest line to graph. It's in the corner of each box, just like that. Sorry, I am. Start at -1, and then you go up like this, and like this, like this. Trying to do that fast. And then down. Just like that. That is a positive slope. You are graphing a line that goes up from left to right. There's two lines that go up from left to right. They should go up from left to right because they both have positive slopes. So this is y equals x minus 1. So the solution is 2, 1. Remember, the solution is where they intersect. That is where they intersect right there. 2, 1 is the solution. How do you know your answer is correct? You can substitute in, and like just so I am clear here to you and you are understanding, the y is 1. So the x is 2. That's an input. So if I put this 2 in for the x, minus 3, that's 4 minus 3. Y has to be 1. 4 minus 3 is 1. That works out. But you have to check the yellow one. So 1 is the y equals the x is 2. 2 minus 1 is 1. That checks. I know that my solution is correct because I could check it. All right, and that's it. So just take a look at this one. Go ahead and try to graph it on your own. Remember, the slope is -2/1. Has nothing to do with the y-intercept, so that's down because it's negative, and to the right, rise over run, because it is a positive 1. The b equals 3. So now go ahead and graph each one. Remember, this slope right here is 1/1. b equals 3. So that's a rise of 1 and a run of 1. Go ahead, try to graph it. We'll come back with the answer. So here is the solution. It is 0, 3. Hopefully you did get that correct. Just remember that when you're graphing a line that has a negative slope, it is supposed to go down from left to right. So I know that the line is correct from y equals -2x plus 3 because it crosses at 3 and it goes down from left to right. The other line is a positive slope. It's a 1, right? Positive 1 slope. The pretty easy slope that crosses at 3. The solution, they both have a y-intercept of 3, so I could tell that it crosses once, intersects once, and at 0, 3. And that's about it. But if you go ahead and put this into the calculator, I promised that I would show you the calculator. You put that in as y1, and then you put the second one in as y2, and you press graph. You could see that what I graphed is exactly what is on the graphing calculator. To press second function graph, you will see now coordinates. Remember, if you are graphing the blue line, which is y1, it's y equals -2x plus 3. You would start at -3, 9 and -2, 7 and graph these points right here all the way up to where you can't fit it anymore. And then for the red, for the y2, you would go to -10, -7, -9, -6 and graph all of those. You notice that 0, 3 and 0, 3, that is a common point because that's where they intersect. And that is about it. So the mid-lesson assessment is right here. What could best possibly be the solution? What could be the best possible solution to the system graphed? So I'm just going to go ahead and put a nice red dot right in the middle there. And it is not a whole number coordinate. So I know that it's between -3 and -4. So that's out and this is out. -3 and -4, it has to be -3.5 and then up to up to D. So the summary here is that the graph of a linear equation is a straight line. It is always straight. The system of linear equations consists of two or more lines. When asked to find the solution to the system, they're asking you to find where the lines intersect. The solution to the system is always a coordinate. It is always in the form of x comma y. The solution to the system could be found by graphing. It could be found algebraically also by using substitution and elimination, and we'll get into that in the second and third lessons. So take a look at this graph right here, and all I want to just make sure that you do know is that this right here is the slope. It is 4/1, and when you don't see another part of like the b, it is 0. So this is called a direct variation. When it goes through the origin and it's a linear function, this is a direct variation. So it'll start with 0, 0, and it'll rise 4 and run 1. This one right here is m equals 1/1. That's the slope. And then the b is 3. So go ahead and graph it, and we'll come back and you just take a look. You could press pause now. So here we go. The y equals 4x, that is the steeper line. It is the furthest away from 0. The slope is the furthest away from 0, so it is steeper than the other line, which is the y equals x plus 3, because that slope is 1. Right? It is a direct variation. I promised it would go through 0, 0, goes through the origin. So that blue line is a direct variation. The red line is not. And it crosses, the solution is 1, 4. If you wanted to check it, you could go ahead and substitute the 1 in as the x and the y in as the 4. So it has to be equal to 4. So the y is 4 equals 4 times 1. The x is 1. So that equals out because 4 times 1 is 4. Then you have the y is 4 here, and then I'm going to put the x in as 1. 1 plus 3 is 4. That checks out. That's how easy it is to actually check it. And that's basically it. So the next one, I'll do this one with you, but the first one is very, very easy. Remember, there's a number here that's that right next to this x is 1. So I'm going to put m equals 1/1. You always put it in rise over run format, and the y-intercept is 2. So I'm going to go the y-intercept 2, which is right here, and then I'm going to graph a 1 slope. Rise 1, run 1. I didn't even put the arrows. It is a positive slope. It goes up from left to right. But if you were putting arrows, you're going to put it up and to the right because they're both positive numbers. And then down 1 to the left 1. Just like that. So connecting, computer has a mind of its own. Again. And here we go. Connecting those points nice and straight, just like that. At the end, you put your 2 arrows, and at the beginning or end, doesn't matter, x plus 2. Y equals x plus 2. You label that line. Try to keep the labels off the graph, because when we graph inequalities, then you will, we have to shade, and the shading won't, it'll cover the actual labels that you put on there. So just keep it off the graph and you'll be fine. Notice that this one, y plus 8 equals negative 4x, is not in y equals mx plus b format. So you cannot do anything with this until you solve it for y. So the way to solve this for y is to subtract 8 from both sides. And then you notice that if you cancel out the 8s on that side, the y is alone. and you have the negative 4x and the minus 8. Remember, you can't combine them because they are not like terms. So now you could identify the slope as negative 4 over 1 and the y-intercept as negative 8. So the negative 4 goes down, and then positive 1 goes to the right. That's rise over run. So the y-intercept, let me just go ahead, the y-intercept is at negative 8. That's all the way down here. And you go down 4, you can't go down 4, so you have to go up 4. 1, 2, 3, 4, and to the left 1. Right? You're doing, like, you would go down 4 and to the right 1, but you can't. There's no graph left because this is only a 10 by 10 graph. So you're going up 4 to the left because there's nothing else for you to do. And just remember, if you go up and to the right, that means you're going to be graphing a positive slope. This is a negative 4 slope. So it's steep. It's a very steep line, and it crosses at negative 8, but it goes down from left to right because it has a negative slope. You go 1, 2, 3, 4, and to the left, 1. 1, 2, 3, 4, and to the left, 1. 1, 2, 3, 4, and to the left, 1. You see how many points that you got there? You could also do this on the calculator, and you should always check to see if the coordinates are correct, but I am not checking. And this is y equals negative 4x. Notice that I am labeling it off the graph just like that. And right here is the intersecting point. So that is negative 2, 0. And that's how you do that. For this one, I forgot to label the lines. So this is line A, and this is line B. So it says, what is the solution to the system to the right? So I'm going to just put a nice big point here, and the solution is 4, 3. It's where the lines intersect. What is the equation of line A? Remember, when we're talking about an equation, it's y equals mx plus b, and the m and the b is what you need. So A is pretty easy to see where the B is, where the y-intercept is. So I'm going to put that as 5. But now I need a slope. All right. So I'm going to look on the line for the next point that is in the corner of the box with a whole number coordinate. So I have my whole number coordinate right here, and I have a whole number coordinate here, and I have a whole number coordinate here, but I want to take just 2 of those points, and I want to make them as close as possible so I could not miscount or anything. And I want to make a triangle for the rise over run. Since this rise is going down, I'm going to put negative 1. And since the run is going to the right, so I go down and to the right, that's a positive 2. So the slope right here is negative 1 over 2. It is a negative slope. It goes down from left to right. You should see that right off the bat. Now, I'm going to have this line B, but I didn't even put the equation together. So now that you have the slope and the y-intercept, it is y equals mx. So the negative half is the slope plus b, which is 5. So I'm just going to move this up. Same thing. I'm going to set up the y equals mx plus b right here. I know it has to be in that format. My m and my b has to be identified. I know that my b is negative 9. That's the first thing I usually go for because it's the easiest thing to identify, which is negative 9. Now I'm going to look, and I see right here, this point, no good. I see this point right here, right? So now I'm going to do my rise over run. So this run is 1, and my rise is 1, 2, 3. They're both positives. This line's going up from left to right. So it is 3 over 1, but I'm going to put a 3 just because I am not graphing this. I am just putting it into the equation of a line, which is 3x, y equals 3x minus 9. And that is it. Take a look at this one. This right here is the same thing that we just did. Just remember that line is A and this line is B. I forgot to label them. So go ahead and see if you can identify the solution and then also the equation of A and B. And we'll come back and just check to see if you are correct. All right. And you could press pause now. So there you go. The solution is -1, 3. Hopefully you did get that correct. The equation of line A is y equals -x plus 2. It crosses at 2. It has a negative slope. It's a -1 slope. So it's -2 over 2 that I got for the 2 points that I picked. So that's the equation. And then the equation for line B is it crosses at 4. At the y-axis, and then it has a slope of +1, so it's y equals x plus 4. And I label the lines like I didn't do on the other one. You must label the lines, especially when you have more than one line that you're graphing. Just remember to label it. So these two equations, now we're getting into it where you're not in y equals mx plus b format. So that means you have to solve for the y. So the first thing that you do is you always try to get the y alone. I always say, if you understand what you are doing in math, then it's not a problem. It's when you don't understand and you listen to a teacher that tells you to do something and you're not really fully understanding why. Well, you're subtracting the 2x to get the y alone. You would never bring things over to the side where the y is. You have to bring things away from where the y is. So that means the y is alone. When you subtract the 2x, the y is alone now. And then I am going to put, see this -2x, I'm going to put that first, and then I'm going to put the 7 later on, all right, second. It is not necessary to do that, but I do that only because I want to just have it in y equals mx plus b format. Because I'm graphing, I want to just go ahead and put this in rise over run. Since the slope is -2, I'm going to put a 1 underneath it, and then I'm going to put the directional arrows of going down 2 and to the right 1. B equals 7, that's the y-intercept, so I'm going to go all the way up to 7 right here and put the y-intercept down. Nice big point, and then go down 2 to the right 1. This is a negative slope. I noticed that it's a negative slope because it goes down from left to right. It is not something that is difficult as far as noticing that it's negative, because you could see that the points, if you connect them, that it will be going down from left to right. And the pattern, it should be consistent all the way throughout. If you have a point that is off, you'll notice it because it's not something that will be in the same pattern as the other points. You'll have to swerve to hit that point, and that means that you made a mistake just on that point. Don't erase the whole thing. Just go ahead and just erase that point and just count again. You can probably see exactly where you got that wrong. So now this one right here is a little bit more difficult, but again, you're solving for y. So the first thing that I'm going to do is subtract the x on either side. So once you subtract that x on both sides, it just doesn't want to draw a line for me. That means this cancels, and then you have -2x, 2y coming down, equals, and you see this -x, I'm going to put that first. The +6 comes down. Now, the y and the -2 need to be broken up. You need to kind of separate them. They are connected right now by the operation of multiplication, -2 times y. So we're going to multiply, we're going to divide, do the opposite of multiplication. We're going to divide by -2, the number that is next to the y. That cancels. And then we're going to just slow it down right here. There's a 1 that's in front of here. It's a -1. So if you have, and I'm just going to do this in yellow because I don't want to make a mess of it. Look at that fraction. You need a fraction to graph. So I'm looking at -1 over -2. When you have negative divided by a negative, everybody should know that that is positive. So if you do -1 divided by -2 in the calculator, you'll get 0.5, and it's a positive 0.5. But I'm going to keep the fraction and it just drop the negatives because negative divided by a negative is positive. So I have a half. Then I'm going to take and do 6 divided by -2. What is 6 divided by -2? That is a -3. Because remember, when you have, I'm just going to rewrite it over here because it's a little bit messy over there. Positive divided by a negative is negative. So now you could go ahead and you could use that slope as 1/2, and the y-intercept is 3. I'm going to rise and run to the right. So I am going to, oh, by the way, this is a -3. Negative. So this is a -3. And then I'm going to go up 1 and to the right 2. Notice that this slope is not very steep. The reason why it's not steep is because it is a slope that is not far from 0. The further the slope is away from 0, the steeper the line. And so if you have a slope of, like, say 6, you know that's a really steep line. If you have a slope of a half like this one, that is not so steep. And remember, this is a positive a half, so it should be going up from left to right, and it is. So the solution is 1, 2, 3, 4, -1. 4, -1. And you could substitute to check it, and that's about it. Hope that helped. All right, so we're going to think and discuss here as far as this goes with all of these questions. They're really good questions. Create an equation of a line that is parallel to this function right here, y equals -3x plus 5. Just remember, to have a parallel line, you have to have the same slope but different y-intercept. Same slope, different y-intercept. So we're going to have the same slope, -3x, different y-intercept. You could put anything. You could leave y equals -3x minus 10, y equals -3x. Remember, as long as it has a different y-intercept, it's not exactly the same line, but it has to have the same slope to be parallel. Creating an equation of a line that intersects the line has an equation of y equals -3x plus 5. Just remember, it just has to have a different slope to intersect once. Different slope. So I'm just going to put y equals 2x plus 5. No, plus 7. So it's just a different slope. It doesn't matter if the y-intercepts are the same. It doesn't matter. Different slopes will intersect. Different slopes. All right, and a nonlinear equation. We're going to write down all of the nonlinear equations. Remember, an exponent next to the variable will have that's a nonlinear equation. The exponent as the variable will be nonlinear also. Anytime that you have a fraction with a denominator of x, if you have a square root of x, anything like that. So just remember, all of that is nonlinear. Linear equations are y equals mx plus b. So anything not in this format, if you have an exponent, they like to have an exponent next to the variable and say which one's linear, which one's nonlinear. It's the one that is next to the variable, right? The exponent next to a variable is nonlinear, but the linear equation, you could just put 3x minus 3. Direct variations go through the origin. Just remember, it goes through 0, 0, and it has to be linear. So the y-intercept must be 0. And that's it for that. So go ahead and see if you can graph this and find the solution. So we have something like this now, and we have this graph right here is y equals a half x plus 1, and we have this graph that is going up from left to right, crosses at 1, looks good. It's not steep because it has a half slope. Then we graph the next one. We have to get it into y equals mx plus b. We subtracted a half x on both sides. I get y equals negative a half x plus 2, minus 2. The slope is negative 1/2, so that means it goes down from left to right, and you can see it does, and it crosses at negative 2. And here's the solution. That is not a whole, like both whole number coordinates. So I'm going to go to try to figure out what this is. This is negative 1, negative 2, negative 3. All right, so it is definitely an x of negative 3, and it goes down a half. So negative 0.5 would be my guess of what that is. So I'm just going to bring up the calculator right now and just show you something here that that I do have to show, or should show. So if we press graph right here, I'm going to clear this out and clear this out and go to y equals, clear the other two lines out, and I'm going to go ahead and graph alpha x. That's how you bring your fraction up, which is 1/2 x plus 1. And then I'm going to go down and going to graph this second line, which is negative alpha x 1/2 x minus 2. All right, I'm going to press graph. And you can see that whatever I have graphed right now is the same thing that's on my coordinate grid. But I just wanted to make sure that you knew how to go about finding the exact coordinate of the intersecting point. And it's very difficult because these are not whole number coordinates. So these are the steps, and I'll go over this once with you, and you could watch it over again if you have to kind of do it, over and over again. So if you have something like this, you press second function and trace. So second function trace will bring you to the calculate screen. The calculate screen will have a lot of things on it, but the one thing it does have on it that you're going to use right now is the intersect function. So we're going to press 5, and we're going to go to intersect. So if you see this cursor right here, you can leave it right there, or you can move it if you want closer to where the intersecting point is. But I'm going to leave it just for demonstration purposes. And it says first curve and has a question mark. I'm going to press enter. Then the second curve, it jumps to, after you press enter, it jumps to the second line. So I'm going to press enter again. And then it says guess. And I'm going to press enter again. And it's negative 3, negative a half. So just take a look, negative 3, negative a half. So that's basically it. Your calculation right here, second function trace, and then you go down to 5, and then you go first curve, you press enter. Second curve, it jumps the lines, you press enter, and then it says guess, and you press enter again, and it'll give you the intersecting point. All right, just wanted to show you that, just in case you have something that you can't deal with as far as the whole number coordinate goes, and you don't know how to see what that is. All right, just remember, both of these lines are not in y equals mx plus b format. Go ahead, solve them, and then graph them and get the solution. All right, and press pause, and we'll come back with the answer next. So you can tell at this point, if you did this correctly, you would add 2x on both sides. You get y equals 2x plus 1 for the first line. You graph it, and then you have you add 4x on both sides. Again, divide by 2, and you will get y equals 2x plus 1. They are the same line. So you're graphing the same line, so it looks like one line. So when you have the same exact line, same slope, and the same y-intercept, the solution is infinitely many solutions. It's infinitely many solutions. The reason why that is because, again, you have every single point that is the same. So if you go ahead and, I'm going to just go ahead and show you that this y equals 2x plus 1, I believe the line is, and y equals 2x plus 1. Let me just make sure. Yeah, it's y equals 2x plus 1, y equals 2x plus 1. Once you have the graph, it goes blue, and then it goes red. It's the same line, and if you check the coordinates, all of the coordinates are the same. It's negative 10, negative 19, negative 9, negative 17. And you see exactly that all of the coordinates, as far as you go down, are exactly the same. So that means there's an infinite number of solutions. Every solution, every input has the same output. So that's it as far as that goes. So we have two special cases, not just graphing systems, but no solution would be when the lines are parallel. Remember, you have the same slope, different y-intercept. Just like the same slope here and here, different y-intercepts. These are parallel lines. There is no solution. There's no solution because, again, they never connect, right? They never intersect, I should say. They never cross. The same line, though, the one that we just did, has an infinite number of solutions, infinitely many solutions for the same line. All right? And if it crosses once, obviously, that is just one solution. So you just take a look at this exit slip, and obviously, I just talked about it. How many solutions does this system have? And these are parallel lines. Obviously, there's no solution here for this. And again, if you go ahead and the fast finisher says to find the equation of each line, so the blue line right here, this line I'm going to label A, and this line I'll label B. The A would have an M, line A would have a B of negative 3, and an M, I'm just going to pick another point, and here's another point, goes down and to the right, negative 1 and 1, that is a negative 1 slope. The equation for that line is negative x minus 3. Line B crosses at 3, so that B is different, but the slope is the same. Again, negative 1 over 1. So it's y equals negative x plus 3. Same slope, different y-intercept, parallel lines, no solution. So that's it. And we are done with the lesson, and I hope that helped. Thank you for watching. See you next time.